Okay, so let me share my screen and
Yeah,
what we're doing today.
yeah.
So it's a little weirder, perhaps. It's been a while. It's
It's
been a
good to
while.
mix up.
Yeah, it's been a while since we just coded something,
Yeah.
and getting to see us use the tools that we like to use in action is always, I think, educational. I mean, I like watching people actually code real things instead of just showing us features off in a vacuum. And over the weekend, I was peeking over the fence to the Rust side of things, just to, heard, okay, it's the most loved language on the Stack Overflow survey, 6 years running. Okay, why? Maybe we can learn something from the world of Rust. And it's a pretty cool language. It's interesting if you're doing something with very low level that you need to be memory safe and very performant. Seems good. I've heard reports of people writing their web apps in it. That seems like a sort of a relatively masochistic exercise, because you probably don't need all of those guarantees and you don't need to reckon with the borrow checker. And it is more of an imperative language, so a lot of the high level DSLs are not there, but it has a lot going for it, and I can see why it is super popular. And one of those reasons is it's just has really good, is a great website. It's a newer language. They have this, what is it, cargo.rs? Is that the website? I think that might be the wrong name. Cargo, whatever. They have they don't have Maven. They don't have, we're not going to rewrite Maven today. They don't have sort of the weird fractured ecosystem. It's newer. They have really good error messages and all that stuff. It's all great. But one thing that they do have as well, in addition to that, is they have some really clear documentation. And they even have these little exercises. So one of the learning paths is this Rustlings repository, which is a small series of exercises that you used to reading and writing Rust code. So you run some shell command, it installs a binary and also a repository, and then you run a little binary command, and it will walk you through a series of exercises. It's actually fairly low tech. It's not too wild, but it seemed like something that could be fun. I like making terminal user interfaces, and I like teaching, and so also making exercises could be interesting. So the goal for today is to try to explore and code up from scratch what might be the Zio version of something like this, or at least the beginnings of something like this. We probably won't get it production ready today. We certainly won't write a whole bunch of real world exercises, but to just explore how we might build something somewhat similar. Hopefully, it shows promise and we can actually turn it into real exercises that will help people also learn Zio. But for now, mostly just a experiment that will have us use some tools in a semi-real world context. So let me just quickly show off what the Rustlings thing is. So that comes once you run the command, it gives you a repository. So let me open this up. It took me to some file here. Let me close everything. And what you're supposed to run is Rustlings watch. And then it gives you this, oops, because I resized my terminal, it got all out of whack, I think. Let me try that again. Rustlings watch. Basically, it runs a compilation. It compiles, rather, an exercise, and it shows you the output. So let me command click onto this, and it'll take me to this exercise. There's some comments. Basically, the purpose of this one, it says, is to comment this line out when you're done. But if you try to run some Rust code in here and you get a compile error, it's going to recompile. So it's watching the file and it's going to recompile and give you an error message. So the goal for these exercises is basically to get these files to compile and then to delete that little "I am not done" comment so that it knows to advance you to the second exercise. And then you can command click on that, go in here, fix there with their little weird string formatting syntax there, and then it should be happy. And you can also type in hint, and it gives you some hints per exercise, depending on which one you're on. So when I delete that, it'll take me to the next one, and I can look at variables 1 now and try to solve that problem. And then run hint, and it's going to tell me the declaration on line 8 is missing a keyword that is needed in Rust to create a new variable binding. So then it sort of gets you, I guess, to look at the documentation. Doesn't give you all the answers, but it gives you a series of exercises in increasing difficulty. And because the error messages are pretty good, that also sort of serves as a bit of a tutorial because it tends to make some recommendations sometimes for what you could actually do to fix your code. So that's kind of what we want to do. Make some kind of terminal app that will run us through a series of exercises, tracking progress, reporting hints, and something like that. Maybe tweak it a little bit. There are some limitations of this this particular Rustlings binary. I mean, basically what it's doing is just your goal is to make it compile. It cannot validate that you've made it compile correctly exactly. I actually think there are some miniature tests it runs, actually, now that I think about it, because Rust has some particular features for having tests run alongside the file. So it actually might run some small assertions as well. So we could certainly do that. But we might have to change it a little bit to make it work for Scala. With Rust, clearly they're not using any imports. If we want to teach people Zio, we'd have to import things. And the way, if you sort of have a huge project in IntelliJ, is it's going to actually try to compile everything at once. And so we want people to become accustomed to actually using the IDEs that they're using, whether it be VS Code or IntelliJ. So we don't want to give them a project with mostly non-compiling files, and then they're not going to be able to actually use their IDE as they would normally. They basically have to ignore the IDE errors and only look at these errors. So we're going to do something maybe a little different. We'll figure out exactly what that is going to be. Maybe we could generate these exercises one at a time, maybe have a separate test suite for each exercise that we can run and report the errors. But generally, we want to have some interactive exercise project. So let's just start from the very scratch. So I'm going to just make a new project. Let me close Rustlings, close that out. And yeah, oh, no, I don't know what I opened. Get out of there. Okay, so we're going to make a new project. Let's make a new Zio project. Thanks to Eagle for that little thing there. Great, so I'm going to go into code and I'll call it, oh goodness, Zexercises, Zio trials. Zio trials. And I'll create that in my code folder, create. Awesome. So we're starting from very much the beginning. So that little command there gets us started with a really bare bones repository. We have a main file, we have a build.spt, and we have an empty test repository. So pretty bare bones. I'm just going to pull some things out. I'm going to pull Zio version up here. And then we're going to add some other dependencies. I don't think we need Zio test SPT. Actually, I think Naveed recently up a PR adding Zio test as sort of a built-in test framework.
That's awesome.
For SPT. So I think in the near future, you won't need to add Zio test SPT. I guess at the next been merged, which is awesome. Yeah. I was thinking of doing that a while ago, but I didn't want to, you know, as someone who maintains Zio to some degree, you know, didn't want to be bothered.
You still want to get into politics,
Yeah. So thank you, Naveed, for on Zio's behalf. That's awesome. I think there are enough people using Zio test, and clearly they agree. The maintainer of SPT merged it in, so that's awesome.
Yeah.
Okay. Great. Anyway, I'll put it there for now, just because that's not out yet. We're going to need a couple of other libraries. One is dev.zio. We have a great miniature library called Zio Process, and I'm not entirely sure what version that is, but luckily, is there 1.0? 0.7.1 might be the newest version. I think that's correct. So that's kind of cool. IntelliJ has those autocompletes there. And then I made a little library that we're also going to use a while ago called Zio TUI, and that is powering basically the Scala update tool I made. So if I roll that version back, and maybe I'll roll Zio version back, and I go into this repository. So let me go into CD Zio trials, and I run Scala update. Hopefully it works. We'll see what happens. We'll get a preview of this tool. Yeah, so basically it's a interactive terminal library. So you can go between, it basically is going to find all the versions that are out of date and suggest new versions to update to. So Zio Process, there's the minor version and also pre-release version, so you can pick which one you want. And then if I hit enter, it's going to update all these dependencies. I basically just changed those back to the way they just were a moment ago. So yeah, hopefully if you didn't know about Scala update, hopefully that you find that useful sometimes. Basically just a CLI version of Scala steward, but sometimes I find that difficult to run locally, and I was just like, let me make my own thing. But we're going to use this aspect of it, the ability to sort of control some kind of interactive terminal, so we can get a similar full screen terminal app like Rustlings gives us. So I'm installing that as well. Hopefully that works just fine. The API is not final there, though it is public, and we'll make it work. Maybe there'll be some rough edges. I'm also going to create a Scala conf file after being prompted here. Look for, I have it in my clipboard, some settings here, and we'll add that. So now everything will format, and now I can breathe. Beautiful. Okay. So let's get started with something. Let's maybe take some notes first. It is good to have notes. Last time Adam reminded me, yes, you can actually take notes and think high level before just diving in and splattering things around. We'll probably do some splattering. But let's start with some recap here, which is we basically need, what are some features, what are some capabilities we need? Well, one is we want to compile and maybe watch, compile, or watch test, something like this. We want to do a file watching recompilation or retest of some Scala directory. That's one thing. We want to parse the results of that compilation, because I think what I'd like the user to see is something like, well, we want that UI. Here's my UI mockup. Maybe have some kind of exercise name at the top, and then maybe above that we want one of those progress bars. Who knows what that's going to look like? I'm sure we'll spend a lot of time afterwards. Ooh, and look, 20%, sure, 1/5, something like that. And down here we kind of want some errors or success. So like all tests pass, etc. Or if there's failing tests, we want to sort of list out what those tests are. Maybe we also want sort of something like source main exercise 1 intro, something like this. So the user can command click on that and open it up in their IDE. But obviously, if there's test failure, we would need to parse that out as well. And if the person is recompiling, if the compiler is recompiling, due to that file watching, we want to maybe like dim out the previous result. And maybe at the very bottom, we can sort of, press H for hint, N for next, etc. So some other commands as well that we can show off for the user to hit. Okay, I think that's basically it. We're going to start from with not all of that in place yet, but that's just kind of a brief sketch. So we definitely need the ability to compile our project. Maybe we can start it just hard-coded to our own project here. And then eventually we'll be able to just redirect the target of our compilation to whatever project we generate for the exercises for the user. So we'll make that configurable eventually, but we can start hacky. And then we want to somehow parse those results, those compilation results, and display this sort of streaming compilation state in a UI form, in sort of as a terminal user interface. So maybe we'll start with this, and then eventually over time we can have particular states of compilation unlock the next exercise button, which will maybe generate the next exercise in the repository with the next set of failing tests for them to work on, and we'll move on to that. So it'll update the UI and all that. But I think there's enough complexity to get started with here, so let's do that. Any questions or thoughts, Adam?
No, I think that's sounds like a great place to start.
Okay, cool. Great. Okay, so let's do it. So let's start with just compiling. So I'm going to make a new little, maybe I'll do sbt.sbt process. I don't know, sbt runner. Let's do that. So here we make a little package. I'm going to import Zio, and I'm going to import zio.process. And Zio.process is pretty great. Let me actually also make a little, have lots of shortcuts here. SPT runner test. So we can just experiment with this zio.unit for now, and we'll run that in a minute. So what we want is basically the ability to have compile watch. So I'm going to say command, which is one of the data types you get from Zio process, and you basically just give it some kind of terminal command and then a series of arguments. So I'm going to say compile for now, watching compilation. So that's sort of our command. And then there are a bunch of methods on this, one of which is, I believe, called lines stream. So this will get us back a Zio stream that will not fail. Oh, sorry, that will fail. It has no environmental dependencies, and will get us back a, oops, I guess I should make underscore there.
Yeah, I thought it was a Scala stream.
Yeah, no. A list of outputs there. So each line, and we can see what that looks like by maybe in here I can say, let's just print that out. So for now, I'll say our program is going to be spt runner.compilewatch.forEach, and then I'll just say zio.debug. So we're just going to print each line we get to the terminal, just debug that. So if I run this, it should run it in the same directory. So we're going to compile ourselves. So well done, SPT, the loading plugin. There we go. So that's generated from Zio here. And then we, it's just going to keep running that process in the background. And then I can, probably have to kill this now or something. But yeah, we get all these lines out. And they're not highlighted because we're just calling zio.debug. So what we can eventually do is basically parse interesting states out of this stream and turn it into something a little more structured. We'll take a look at that in a minute. First, let me make my console font larger so we can see when I do that again. I don't have to keep zooming in. So yeah, let's make a little piece of state that we can use. So I will say CO traits, SBT state, I guess. And so I might want a few states. I want, I guess, a loading state for when we start the project. I don't really care about any of this information. Maybe I want a success state, so success, and then some kind of message there that will extend SBT state. So I basically want to have this information that it completed. And then, of course, if there's an issue, which is going to be hard to show in this file right now because it's already, it's the file we're running here. Actually, no, here, if I run it first, because it's running file watch compilation, I'll have it run, and then I can get it to fail by typing in some nonsense. So now it's sad, and we have error. Luckily, these are prefixed with this error bit, so we can just sort of grab anything in an error here and sort of grab all that information and put that out and store that. So let me do that as well. I'm going to say error, and then I'll just have lines here, which is going to just get me, maybe let's use a Zio chunk of strings. So we're going to basically want to grab all of, where'd it go? All of these lines, once we get the first error, switch to that error state, and then just store all this in that chunk so we can display it on the screen. And we don't care about the success message anymore. And maybe also, because every time I, let's say, fix something, so when I hit delete here and save, it's going to tell me build triggered, and it's going to recompile. So maybe I can have this go to some other state, let's say rebuilding, and maybe we want to store the previous SPT state in there, just so we can still display it, but maybe we'll have this extra bit of information telling us that we can dim it out. So now let's use this. So our goal would now be to, if we had this state, if we had some of this state, we can render it to the terminal. But now our goal is to sort of take this stream of strings, essentially, and fold over this somehow to turn it into a stream of SPT state. And the operator we want to do for this is actually called scan, because fold would sort of wait for this string to finish and process it into one terminal result. But we want to sort of accumulate and transform this state using both the previous SPT state and all the new lines we come in. we get in. So for instance, if we first see, let's say success or whatever it was, I forget exactly, we'll have to look at the output again. Actually, let me do that. Let's go run. So success, yes, that is it. So if we see success, let's just simulate this. We're basically going to start with loading. So state is in loading. And then if the success word comes in, we're going to translate, transform our state to be a success of whatever that string is. So cool. And then if we get something like error, well, then we're going to steal whatever is the rest of that line. So let me actually create an error here. So when we get the first error, we're going to switch to this new state, which is going to be that whole line, basically. Where'd that go? Great. So we're going to get that first line, but then we're going to get another error state, which is that bit, right? We're going to get the second error line that's going to come, AEU, and then so on and so forth. And so we want to take whatever is here and append that to our previous list of errors so we can render all that, because we're getting these lines one at a time, but we want to sort of add them together to get that full image of the error state. So we're going to be processing these errors as well as their previous state. So it seems like fold, but this is called scan in this case, because we're going to keep emitting our state as it changes. Great. So let's actually do that. Let's write our little parser here. What is it called? SBT state stream. So I want to first call compile watch to get that stream. Maybe I'll call it compilation compile stream. And then I will call scan. And the arguments for scan are, if I jump over here, going to be the state. So we're going to start with some state, and then we're going to have this function that will take the previous state, the line that we got in this case, and we're going to generate the next state from there. So basically the same signature as something like fold left on a list, except we're going to keep emitting each intermediate state. So in this case, we want to start with, I guess, SBT, state.loading. And just because, I think we talked about previously, at some point, the way Scala type inference works is it's going to affix that S to whatever it can infer the narrowest type in the first parameter list. And because SBT loading is its own type, SBT loading, which is a subtype of SBT state, that's basically going to lock us to only being able to return loading, but we don't want to do that. So we basically want to widen that to be any SBT state. So we can either give a type description on scan, or we can widen that here, or something else. But I'll just put that there. And now we can write our code. And I think I will do a case on this stuff. So we can match on both the line and the state simultaneously and do some things. So let's think about all the states that we care about. So I think at the beginning, we sort of don't care about what the previous state is. Let's just think of certain lines that might occur. Where did the running thing go there? There we are. So if we get a success, it doesn't really matter what our previous state was. We're going to throw it away and replace it. So let's start with that. And one really cool thing you can do in cases is sort of like a poor man's regular expression. There's actually a pattern matching syntax for string interpolation, string deterpolation. I don't know what you'd call it. Destructuring syntax.
Destructuring, yeah.
It works great for cases like this where we don't really care too much. Basically, yeah, it's kind of fun. I'm not sure if everyone's seen this before. Whoops. But it's pretty powerful. So we're basically going to match on a string that starts with success and then bind the remainder of the string. So yeah, pretty awesome and very useful for our purposes here, a sort of hacky parser. So now that we have this, we're going to say SBT state.success of, yes, the message indeed. So that's one thing we want to do. Now let's look at an error. And to do that, I will just get it to fail. Oh, there we go. So let us next look at error message. So there are two cases here. One is if the previous state was an error, previous lines, then we want to concatenate and append What is previous? Oh, because it's SBT state, it's confused. We want to append, or appended, I should say. We want to append our new error message onto the old message. I'll just call that lines. We're going to add that message. But if it's anything else, we want to switch over to the error state. So let's break these all apart. Great. And what else do we have? Yes, there's the rebuild. So let me get it to rebuild and see what that looks like. So it's going to say, what was it? Info build triggered. So that message we're going to also match on. And it doesn't quite, it kind of actually does matter. Let's fix that in a sec. Info build triggered, and then followed by literally anything. We don't care about capturing this message. Then we're going to take our old state and just nest that. Unless, of course, our old state was SVT state dot rebuilding, in which case we'll just keep that old state around. So I'll say state, we'll just keep rebuilding. So yeah, pattern matching syntax plus the string interpolation, pattern matching on tuples in this case, pretty powerful stuff. And I guess for now, if anything else occurs, we'll just propagate the old state. I don't think we care for now. We might want to do other things when we want to parse test output. We might have to complicate this a little bit, but for now, this should work. Let's see what we get. I'm now going to say SBT state stream. SBT runner state stream, and then we will do for each basically zio.debug as well. Cool. So let's see what we get when we run this program instead. Loading. So it starts with loading, because it's scanning. So we could have it collapse duplicate outputs, which might be fine. And then we get what seems to be 3 successes. Cool. Don't really know why we got a 3 times. Maybe it outputted it a bunch of times. And then rebuilding. And then a whole bunch of chunks where we slowly append each time the new messages. So we should have everything we need. Great. So that's fine for now. And we could probably use this output to render to the console. Is there a combinator for just like remove duplicates or something like this? I'm not that I think it really matters. I'm just curious if that does exist.
Yes, there is. Let me try. I think it's called maybe distinct with. I think it only removes consecutive duplicates. Because the problem is if you want to remove all duplicates, you need to maintain a set that can grow in unbounded size.
Consecutive duplicates is fine. Which one is that called?
Oh, let me find that one for us. Hold on one sec.
I'll keep moving in the background because it's not so important.
Yeah, exactly.
Yeah, it's not going to be a problem with when we make our TUI. So yes, while Adam's looking for that, let us create our terminal user interface. So
changes.
Just .changes. Yeah. So yeah. Only changes. Changes. Returns
changes.
That only emits.
You don't want to hear me sing. That's like that's like a crime against the Zymposium.
So yeah, only changes. Okay, interesting. All right, I guess that makes sense. You're only getting the changes. My naming DAR is going off. Naming. Maybe we could have something like distinct. I think is to keeping the. I guess it's not exactly distinct. Yes,
it's not distinct. Yeah, that's the thing.
Maybe consecutive, distinct. Yeah, lapse, remove. Whatever. It's hard.
I think we may have a couple of years before ZO3 and another round of the naming.
I'll ascend the mountain for 2 years and think of a name for that. Cool. And by the way, before I switch to the other file, does this all make sense to everyone? Is this any questions? I'm getting very ominous lighting off my floor right now. But all good?
Yeah, I think so.
Okay. Let me lean away from the reflected light. Hunch over more, get into that live coding zone. Posture must be sacrificed for productivity. Okay, so yes, make a TUI app. So I'll call it TUI app, or I don't know. I'll just call it CLI. Yeah, cool. And it probably shouldn't be in the SVT sub package, but we're going to break things, move back, break things, etc. So I'm going to import all of Zio again, and then I'm going to import my TUI library. So I think I need to import TUI and then TUI dot view. I have to work on the names here, but I think that's what we want. Might have to change some of that. And so the way this works is to get this terminal user interface going, you actually want to extend. There's a trait that it comes with, which is maybe a little strange. And it's a bit like the Elm architecture. And I'll just show this. So I think it's called terminal app, and it has 3 inputs. One is some kind of input that it optionally could receive. So this could be nothing, or I guess any. Then it has some kind of state, and then it has some kind of result, which these can be composable if you want to sort of, once the user has hit enter, you're making them select, which libraries they want to upgrade. You can have this return like a list of updates or something, but we don't want it to return anything. It's just going to basically be the whole app running in here. So I'm going to make some kind of state here, and we'll look at what that's going to be in a second. But basically, we could just I think use the SPT state as one of the parameters here, and we can have others later on. Maybe I should call it CLI state, not sure. And then for the input, we want this to receive the streaming output from the SPT runner. So we want to be able to respond to those sort of external events. And yeah, this is sort of similar to the Elm architecture, or if you've used, if anyone's used the brick library in Haskell, you need to basically be able to process those. So we're probably going to make that into SPT states as well, because we're going to receive those. So I'll say SPT state from our stream. And then I'm going to implement the members, and we'll see what the heck this means to be a terminal app. So the first thing we need to do is go from our state here to some kind of view type. So this is the render method. And then we have this update method that we need to implement, which is going to give us our previous state. So the runtime is going to call this with our previous state, and then some kind of event, which is either a user keyboard event or one of these streaming inputs. So we can respond just to sort of the user hitting up and down, or the H key for the hint, or Q for quit. But we can also respond to receiving some kind of external streaming input, which is what we're going to do eventually. Okay, so let us write some of these. Maybe I'll start with updates. So I'm going to match on. Do I care about matching on state? No, I want to match on the event rather. So matching on the event. And there are 2 things. So the system event is going to be something like, I think it's key events dot character. So we can match on like the Q key to quit or something. The user event, this is going to be whatever our input type is. So in here, it's going to be a new SPT state. So what we can do here is say terminal app dot, I believe it's dot step dot, and we have a couple of options. We could either use this event to quit or to return a value, or in this case, update ourselves. So basically when we call update with a new state, it's going to call render again with that new state and clear the terminal buffer and re-render the new view, and then wait for more events and so on and so forth. So a pretty basic model view update architecture that's sort of Elm or Redux or Brick style. So basically one of the simplest pure functional architectures you can have. And it works pretty nicely, I'd say. If it's something like quit, I can say terminal app.step.exit. And for anything else, we're just going to I should add no change, but for now I'm just going to update with our previous state. So if it's anything that's beyond either an external event or a key character that we handle, we're going to just remain the same. But yeah, no change probably would make sense. Okay, anywho, render that. So now we need to render our state before we can actually even think about running this application. So what do we want to do here? We need to return a view, and there are a few different ways of doing this, but let me say view.vertical. So this will allow us to, whatever we put in here will render vertically atop one another. So if I have one thing and then another, it's going to render like that. So at the top, I guess what I want to say is something like Zio exercises, and then maybe have some kind of dashes below it of the right width. We'll see. And these strings can get turned into a special view type that have their own sort of methods on them. So I could do .blue and .dim on them, so it'll look a little pretty. And then at the very bottom, we can have sort of our commands in a view.horizontal block, which will render them horizontally. So I can say something like a q.blue, and then is equal to quit. I'll make that dim. So we'll see those things along the bottom of our screen. And then in the middle, this is where we want to render. So private def render SBT state. So SBT state, and then we want this to turn into a view. So I'm basically going to match on whatever the SBT state is, and we can figure out how we want to handle that. So loading can just be, loading ... and maybe I'll make that dim. Success, this could be the message .green. Error lines, we can say lines .map, and then I will just say, I think it's the view method on this should change it. Oh, view.text rather. So we're going to turn those into text, and then we're going to turn this all, put this all inside of a vertical block. And I think I need to spread those out. And lastly, I'll make those all, I don't know, blue. Oh, that's no, red, error. And finally, rebuilding, I will just call this recursively and then make it dim. So that's kind of the idea for the rebuilding state. We're just going to render the other states. And then all I have to do is say render SBT state. And then maybe I'll put some padding of 1 pixel around this whole thing, add in an empty line there, and hopefully it should all look okay. We'll see in a minute. Okay, I think it'll work. Let's see. Okay, so now we actually have to run this thing. So it's our CLI app here. Let me go back to our other applications. So maybe I'll comment. No, I'll just use this. So what was it called? CLI. So how do we make a program out of this? So I'm going to say CLI. No, actually, rather it's TUI. So a little weird. I have to import this TUI thing. Run with events. I give it then an app. So I'll use my CLI app there. And then I have to give it 2 arguments. An event stream that will give it its input, which in this case is going to be that SBT runner.state stream. And then I give it a starting state, which is going to be, I believe it was just called state. And then it needs that loading state in there. So we give it the initial state as well as a stream of inputs. And now if I try to run this, we should get a nice friendly error message, which is that we need TUI in the environment. So I'm going to say TUI.live, and it takes an argument whether or not it should be full screen. So it can render the same app in a full screen manner or sort of not. And I'll have it not be full screen. I don't know. For now, I'll do that. Maybe eventually we'll make it full screen. And it's kind of annoying to run terminal apps inside of SBT. So especially inside of IntelliJ. So I'm going to run it here. I'm just going to say SBT run. Hopefully I only have 1 executable and it should figure out what the main should be. Nope, there are 2. I'll say, I could delete. Actually, I do not care about main. Do I care about main? I just notes in here. So let me delete the body. But for now, I'll pick 2. And we should see loading. Loading. Hey, completed. So now if I add any text in here, it should recompile, and there's our error. Not found value A. So yeah, kind of cool. And all that stuff. And it kind of tries to intelligently render just as the width of the terminal, but it does some horrible things there. If I recompile, now it's good, and so on and so forth. So we get a little bit of something where it's not. Oh, I have too many dashes. Too many dashes. How many dashes? 2x? 1, 2, 3. 3 too many dashes. Oh, I could have just seen that here. Okay. Then if I hit Q, it'll quit. Yay! And it'll also quit SBT because it's hard to run an interactive terminal app from within another interactive terminal app. They tend to step on each other's toes. So our exit code propagates too far, but whatever. It's not the best manual testing cycle, but it'll do for our purposes. So that's basically step 1, is that we have some idea of maybe how we're going to get some kind of streaming state out of SBT for the results of our compilation. And we can render that to the terminal and yeah, have it look good, hopefully. I'm going to say Scala update real quick. Will that give me, no, because there are no updates that need to be made. Let me go to 0HTTP real quick and Scala update, because I'm a, I'm a freak, and I have this little this dash that does not have gaps in it. So let's use that dash, and that'll look so much better. Cool. Great. So yeah, I've basically stolen my old design from there. Yeah. So does that all track so far? Pretty straightforward, I think. Maybe pretty easy, hopefully. But if there are any questions, okay. Great. So what should we try to do next? So let me go back to the main application. So we kind of did, we can check some things off. We want to compile. Yeah, we can compile. We want to parse the results of that compilation. Sure. We want to display the streaming state to the TUI. That's great. So far, though, there's no real concept of the actual app we want to build, but we have some mechanisms in place to make that easier. So we kind of need somewhere to have a data model of what the actual exercises are going to be. We need to have what the code for those exercises should be. And basically we want to create a project for the user and then run these exercises and report the compilation state and have them be able to trigger the next exercise as they desire. I think so that is a lot. So I don't think we're going to be able to get to all that today. Maybe though, it would be nice to not just have compilation, because as I kind of mentioned, that's how Rustlings does it, but it's a bit limited. All you can really do is have it compile or not compile. I guess Rustlings does, as I mentioned, have the ability to run tests. But I think just due to the differences of how Rust works and the fact that they're not trying to also really import any external libraries, and they're just sort of teaching you the basics of Rust, we want to teach people Zio. It's going to be difficult to sort of isolate each of our files. So if one doesn't compile, how are they going to run the next exercise? So we probably want to parse test output in particular and kind of use that to trigger whether or not the user is done with a particular exercise. So maybe I'll switch from this neat, we got that to work with basic compilation and basic errors here. Maybe we should next trigger something a little different so we can run just a single test suite at a time or something, which is luckily possible. We can say SBT test only, and so on and so forth. But let's sort of just play around. This is where, we're just experimenting. I'm not sure what's going to happen. Let's make an exercises repo, and I'll say, E1 intro dot, start with that. Make that an object there. One might imagine a very simple exercise would be hello world is equal to something, and the user has to complete that. So I'm going to use this little shortcut, Command-Shift-T, to create a new Zio spec. And I think I need to say Zio spec default, hit OK. It's now created a test file inside of the right directory. So now we're inside of test Scala exercises E1 intro spec. So we're doing it all in the same repository. I don't think that's eventually going to be the target state, but so we can just make some advancements. Let's keep hacking along like this. So let's see what happens. I'll say sweet E1 intro, assert true. And we want to say that hello world should equal hello world. So if we run this test, it should basically fail. And it's going to tell us something like this. And we're going to get this output. So let's run this with our little terminal application. So I'm going to say SBT run. Oh, it's running compile though. It's not running test. So let's change it real quick to say test instead. And I'm not sure actually what's going to happen now because it doesn't. I don't think this will be prefixed with the word info. But let's see what happens. And maybe I should switch back to the raw output because that's what we're going to have to be parsing. So it's saying loading. I have a feeling it's just never going to change from loading because it. Never mind. It gave me something. Okay. Failed test exercises E1 intro spec. That's okay, except what we don't have clearly is the actual test output. So let's see what we actually get when we run something like that. So I'm going to, maybe I'll keep this around. And then, call this demo, whatever. Naming is going out the window. Have to move too quickly for naming. Let's just run the SVT. What was it called? The compile string, which is now set to run test over and over again. And let's see what we get here. And now we can run it in IntelliJ. We're not doing an interactive app yet. So it says info, multiple instances is not supported. Okay, great. So it looks like it just starts with this. And then, yeah, the reason why we only saw this in our interactive process was because that's the only bit that's prefixed with error. It seems like it's just outputting the test results, the actual test failures that we care about in this other format. So what we could do a few things. It depends on what our goal is exactly, but we pretty much want to render the test output to the user. And so we don't really have a great prefix except for just the plus key, or the plus symbol. So we can pretty much wait until a line starts with plus and then kind of go until we get some kind of, I guess, this indicator. I'm not sure. Hopefully it looks like we do not do correct pluralization. So one test. So that's good for our case because it's less to parse.
Project for Bill.
Yeah. But for now, we'll take advantage of that. I guess, yeah, we're going to look for something that starts with some number test. So we're going to go from some line that begins with plus and until that. Great. And then maybe we actually want to ignore some next set of errors. It's going to be a little tricky because now we have this other state that we want to parse. And we basically want to start parsing that from the plus and keep going, staying in that state until I guess we get to some kind of total time indicator or something like this. So let's change our test. Let's change our little output here to say, instead of error, let's say test output, which is going to look similar. It's just we're going to parse it differently. So basically, case SBT, I guess for any state, doesn't matter. Once we start a line with the plus, actually, when we're probably not in a test mode, once we start a line with a plus, and I wonder if that's going to parse it correctly as well, because maybe that line is colored. So I wonder if we're going to have to also match on ANSI coloring input, because technically that is part of the output here. It's just not displaying it. I think it could be, we could be removing it as well. I'm not really sure what we're getting. So let's just see what happens. Let's actually just say print line. Let's say throw unexpected plus. Let's just see if that gets us anywhere. So hopefully this will blow up. Oh, because I'm not parsing it though, so nothing will happen. So let me do the SVT state stream and debug that. Maybe I could debug them both in parallel, so we get an idea. But that'll be a lot of stuff. Does it blow up? It does not blow up. So yes, my fear was it does not recognize that plus at all, because it is wrapped secretly in ANSI escape characters. So that's not particularly fun. But let's see. We could strip out the ANSI codes. Is that a real plus though? That could also be like a different plus character.
Yeah.
That looks it's slightly different. It's, I think, unless I've gone absolutely insane. I might have gone insane. Is that different? Are these different? Help. It's probably ANSI. Let's see. So yes. But that would just be something I believe, like if that is the case, scala.console.green, and then plus, and that should still match because it's a literal string. But yeah, not entirely sure. Let's see. Maybe we could zip these in parallel. Compile stream. How could I do? What kind of cross par? Adam,
what do you want? What do you want? You want to pull from each of them pairwise?
Yeah. Or
zip par?
I could do the latest one. Zip with latest is fine.
Oh,
actually.
there you go. Yep. That's all. That's a nice operator.
State stream, and then we will. Yeah. Oh, it seems to be sad. Why is it sad? Oh, because then we have to figure out how to tuple them together. I'll tuple them up, and then we'll print them both out. So we should see. Well, it's not going to be line by line, but that's okay. We're just going to see the latest for each. So it's going to be very noisy output, but we'll at least see, does it start failing? Does it blow up? It should blow up actually. So if it Okay. So where do we get the plus? So yeah, that clearly did not trigger any kind of state change, that green plus there, which is a bit of a bummer. I wonder if it's because maybe, let me copy that plus again. That plus looks weird, but I could just be hallucinating. Let's try that. Oh yeah, this is a real world silly coding. I could probably do something smarter here, but let's try this one last time. Yeah, it's definitely not exploding. It's definitely not parsing that successfully at all. So it's clearly somewhat different. Yes. Unless I'm matching something completely different. But no, it should. It's getting that E1 intro. What I could do is, one thing I could do, actually, and this, because we have, thinking about it, we can make our lives a little easier. We have complete control over these test suites. We're going to be generating them. So I could just say something like, exercise suite, begin or something. One exercise, one intro, right? We could do something exactly like this. And then what I could say is exercise suite 1, do that. So for now, we can just hack ourselves around because we have control over the input. And I will say line or whatever, output, no, line, I guess. If line dot contains, dot contains exercise suite at some point. And we'll do that. I could probably do something with the matching there, but let's see if it matches this. Let's see if this blows up. This should blow up now, I think. It's definitely going to be in the output. So if we start all our suites with that, that could actually trigger that this is the true beginning of the output. And it did not fail. Why is this not failing? Exercise suite. I'm confused. That's definitely there. Oh, wait a second. Am I on the wrong side? No, I'm not on the wrong side. Do I get this line? What if I just print anything it doesn't match? Now I'm just confusing myself. Print line. Oh. But yeah, maybe here's the sludge of real world development. Okay, now it blew up. That's great. Unexpected, unexpected plus. It's obviously not what we got. And yeah, I actually don't see the print line either. I don't know why that happened. Oh, because it's just going to print on the first line. It wasn't that one. That's really confusing to me that I couldn't find exercise suite. Why is that the case? Did I misspell it? Am I a fool? Is it because it's in red? There might be some other stuff going on. It really should fail. Try one last time in here to say if line dot contains, how about just exercise suite? I might need to do something like strip ANSI codes to see. Oh no, it's not. Yeah, it's not finding that line. It's super weird, because that word is there. Let's see if it surely could find the word exercise. Okay, no, it's not. It's very weird to me. Exercise suite loading, not failing. Okay, well, also there's the matter of it being minus, so that's probably why it wasn't finding it at some point. But oh no, there it is. Exercise suite. It starts with that, and then it proceeds to fail. So yeah, that's pretty odd because the word exercise is there. Let me make a little helper called strip ANSI codes from a string, and luckily, Copilot will help us here. So maybe that's why. Let's see. So also, I could say removing ANSI. Let's make ourselves a little unapply matcher, which is going to just strip the ANSI codes. What that will allow us to do is inside of this, I could say removing ANSI codes, or what was it called? Removing ANSI line. There we go. Now it should remove ANSI. Hopefully. And then hopefully it should even start with a plus. Theoretically, I can go back to that other version, but let's just do line.contains exercise. Weird stuff. Hopefully that all works. I'm just trusting the Copilot to strip things away from me. No, it's just totally failing. Line.starts with plus character. Should really after being deleted. I'm clearly failing in some huge way here. Oh, yeah. What am I doing? SPT state stream. Yeah, so it's not, it's clearly getting the line. And it's not in an error state. It's definitely in a loading state, but it seems to just fall through everything. So it's not matching that particular line. Am I crazy? Is that being output here if I do SPT test? Anyway, I think this might warrant some other offline
Yeah.
explorations. I don't want to torture everyone for the rest of the day, but basically the beginning part of this was maybe more interesting when we were actually able to make progress, and now in the nitty-gritty of parsing particular characters off of this stream, I am doing something that's deeply confusing to myself, and yeah, I'm just gonna have to bang my until this works. If there are any thoughts as to what I'm failing about, you'll know the test names anyway, because it's, could you use that? Yeah, exactly right. I'll have to know the test.
Yeah.
That was what my thought was there a while ago, but it seems to not even parse anything in that line. So I don't know why contains is failing me. I'll poke around a little bit more and see if I can get it to explode, but I don't want to torture everyone here with that.
Yeah, I have a feeling in an hour it's going to be completely obvious to you. That's at least my usual experience with stuff like this.
It's going to be deeply obvious, but yeah, if anyone thinks this is a cool project, I'll probably push up Zio trials, or maybe I'll rename it to something better, and I'll share it in the
Zio trials. It sounds it's like the ordeals of Hercules.
Exactly.
Zio ordeals.
That would be better. Zio ordeals. That's the better one. Yeah, I'll push it up to GitHub, and once it's in more of a stable state, if anyone wants to hack on it with me, that could be fun. Add some exercises. Hopefully it'll be a cool thing to have. If not, a decent showcase of Zio streams and Zio process, and some patterns you can use for making your own CLIs if you feel like that is something you wish to inflict upon yourself. Great. Well, thank you. With that being said, that's it for now. Oh, don't you need to capture the result of X removing line ANSI? Well, what is going to be in here is actually going to be the version of the string with the ANSI codes removed. So it really should match on everything. The only problem is that it seemingly does not start with the plus character. So I don't know why it's not starting with plus, or even containing. Okay, last try is contains plus. Doesn't contain plus. Certainly it contains plus. That's a single character. It should be in that line. It's not really what I want to fail on, but hopefully it should fail on that line. Come on. Otherwise, I'm deeply nope. It seems to be totally happy. I'm doing something stupid. I'll look at this more often.
All right.
But yeah, thanks everyone.
How hacking works. Yeah. Thanks everyone.
Okay. See you next week.